1.3 piecewise functions. Here we go, pre-calc. We're going to start off with these two graphs. Again, this B is something that you graphed a lot of, so that one should be familiar. This one over here, maybe not so much, but I know you did graph quadratic functions in Algebra 2. But anyway, you may not have graphed it the way that I'm going to do it right here. So x minus 1, if you remember the parabolas start out with a vertex of 0, 0, and then they kind of go 1, 1, and then 2, 4, and so on, and then 1, 1 over here, and 2, 4. So the general parabola is going to look like this. The parent function will kind of have this look to it. But this minus 1 means that the whole thing is going to be moved to the right 1 unit. So let me show you what this graph looks like. So right 1 unit means we have a point here, and then we would have this point here, and then this point here. And again, I know you may not have done a whole lot of these, so just bear with me here for a second. So this is what your graph of y equals x minus 1, the quantity squared. That's what this would look like. And you probably did that with a table or something like that in Algebra 2. Now, all I want is the parts of this graph for the x values that are greater than or equal to 1. So right here is where x is 1, at this value right here. So anything to the left of this value, I'm going to get rid of because I only want the values that are greater than or equal to 1. All right, so I'm going to eliminate or erase all of that stuff that's to the left of that point. So I'm just going to go ahead and erase everything that's to the left of 1. This graph over here, remember from Algebra 1, we have a slope of 2, which we probably wrote as 2 over 1, and we had a y-intercept of negative 1. So I start with a y-intercept of negative 1, and then I do my slope, which says up 2, right 1, up 2, right 1. And you could repeat that to the end of the graph. You could also go down 2, left 1, and we can see that these points are all on the same line, down 2, left 1. So we could do that if we wanted to. Now I'm going to graph the entire thing. All right, so hopefully you have a nice straight line. Mine's kind of a little wobbly there, but that's all right. Should be a straight line. If I had the option of doing that, it would have looked like a nice straight line. But anyway, this is what we got. And again, I just want the values for x that are greater than or equal to 1. So right here is where x is equal to 1. Okay, this is where x is equal to 1, so I'm going to eliminate everything to the left of that line. So I'm going to start down here and I'm going to erase until I get right there at 1. Alright, so that's all I wanted there. Now you might be wondering, why in the world are we graphing and then erasing stuff? But that's kind of how we're going to approach these piecewise functions, okay? So I'm going to graph them separately in different colors so you can clearly see which graph represents which line. So the blue one will be the graph of x, and the red one will be the graph of negative x. So basically what I'm doing is I'm graphing this line y equals x. This is the blue one. Okay, so this has a y-intercept. It has a y-intercept of 0, and it has a slope of 1. The number in front of the x is a 1. That's your slope. B is the number after x, which since there's nothing there, it's a 0. Okay, so b is 0. So I start out with a y-intercept at 0, and then I have a slope of 1. Up 1, right 1, up 1, right 1, and we repeat this as many times as we need to so we can get a nice looking line. So that's going to be enough for me. So we'll connect the dots. I'm going to do, again, I'm doing the whole thing. I'm going to start out with the whole graph. And then I'm going to erase what I don't need. So this is I only want the x values that are less than or equal to 0. So all of these values to the left of 0 are the ones that I want. So anything bigger than 0, I'm going to erase. All of the x values that are greater than 0, I'm erasing. For the red line, I have y equals negative x, which has a y-intercept again of 0. But this one has a slope of negative 1. So I'm starting with my point at 0. I'm going to do a little bit of work here at that point later on, you'll see. And then from here, I'll do my slope of -1. So I'm going to say down 1, right 1, down 1, right 1. Again, as many times as we need to till we know we can get a nice line. We could also go up 1, left 1, up 1, left 1, and that will still give us the same line. So I'm going to graph the entire thing. Oh, that was terrible. Let's try that one again. That was even worse than the other ones. Let's try. I don't know what's going on there. It's not working out. But anyway, there we go. And over here. Oh, my word. Let's try that again. Anyway, you get the idea. That should be a nice straight line. So anyway, this is only defined for the x values that are greater than 0. So any x values that are less than 0, all the x values over here for the red function will be erased. We're going to cross them, not cross them out, we're going to erase them. But the other thing I want to point out is that these are all functions. And another thing you should remember from Algebra 1 is that a function has to pass the vertical line test. So do you see if I draw a vertical line here, it's going to hit this graph twice. So that's something you can do to make sure that you have erased the correct part of your graph. But anyway, I'm going to erase everything to the left of 0. And you can see I erased a little bit of 0, and I'll show you why. So for this one, x equals 0. So that one will be a filled in dot at 0 for the blue graph. But the red graph, because it was just greater than, that is an open circle. Maybe you remember that stuff from Algebra 1. Now your pencil isn't going to show up in different colors, obviously, so you're basically going to show your graph filled in there because, like I said, they're going to be the same color. So this is what our final graph looks like. Okay, so this is what we're going to do when we're graphing piecewise functions. We are going to graph them, the entire function, so the entire function of negative x squared, and the entire function of negative absolute value of x, and then we'll erase the stuff that we don't know. So from Algebra 2, you should remember that from Algebra 2, the graph of y equals negative x squared is a downward facing parabola, like this. Okay? So we're going to graph that a little more accurately here. So we have the point 0, 0 is the vertex. You can plug in numbers if you want. If I plug 1 in, 1 gives me -1. 2 gives me -4. So 2, 3, 4. So 2, -4. I'm sorry, -2, -4. If I plug +1 in, +1 gives me -1. And +2 gives me -4. So this entire graph will look like this. Okay? That's what your entire graph looks like. Now, this is only defined for the x values that are less than 0. So all of the values less than 0, the ones to the left of the y-axis, this is where this graph is defined. So anything greater than 0, all of these values greater than 0, I'm erasing. I'm also going to come back to 0 and put an open circle because, like from Algebra 1, less than means an open circle, where greater than or equal to is a filled-in circle. Alright, so my other function, y equals negative absolute value of x, you should again remember from Algebra 2 that the absolute value of x function looks like this, a downward facing v. Okay, now hang tight while you graph this one because I have the ability to erase some stuff and make it look okay, where on your paper it might not look very good if you do what I'm about to do, so just stick with me here for a second. The right side, if I plug 1 in, absolute value of 1 is 1, and then the negative will make that a -1. And if I plug 2 in, the absolute value of 2 is 2, and then the negative makes that a -2. And I can do the same thing for 3. The absolute value of 3 is 3, and the negative out front makes that negative. So the right side of this will look like this. As we can see in the last thing, I cannot draw a straight line. So that's good enough, though. The left side, if I plug in -1, okay, absolute value of -1 is 1. Negative out front makes it a -1. So I have this. Don't do this yet, just bear with me for a second. The absolute value of -2 is 2. Negative out front makes that a -2. And the same thing for negative 3 would be that. So this entire graph would look like this. And then again, I want to eliminate all the values to the left. This is defined where x is greater than or equal to 0. So all the values to the right of 0 are part of my graph. Anything to the left of 0 I want to get rid of. So again, like I said, I have the nice ability that I can just hit my back button and I'll end up with that. Alright, so this is your final graph. This is what this should look like. Next, x squared. Again, I tried to stick with some basic functions, so either x squared or absolute value of x. We're not going to move those around, but then we'll have some linear functions that'll be moved around a little bit, okay? So this is going to be my blue graph. So let's start off with that one. Y equals x squared. And again, if you don't remember what they look like, just plug in some numbers. If I plug in 0, I get 0. If I plug in negative 1, I get 1. If I plug in negative 2, I get 4. Alright? Let's go the other way. If I plug 1 in, 1 squared is 1. And if I plug 2 in, 2 squared is 4. Okay, and you could also make a table. This is probably what you did in Algebra 1 or Algebra 2. Like I can use negative 2, negative 1, 0, 1, 2. Okay, you can use those values. And you'll get 4, 1, 0, 1, 4. You just plug those into your x squared. Alright, so those are the points that I have right here. So I'm going to connect them. Play connect the dots. Connect the dots. There we go. Alright, now from here, now I'm only defined for all the values that are less than negative 1. So right here is negative 1. So all the values that are to the left of this I want to keep. So anything to the right of this I want to get rid of. Okay, I'm also going to get rid of this little note here. What goes at negative 1 here? If you said filled in circle, you are correct. So this would be a filled in circle right here. Because again, it's just less than. Okay? For my red line, this one right here, y equals x plus 2. Your slope, the number in front of the x is a 1, and my y-intercept, b, is 2. So I'm going to come up, start with a y-intercept at 2, and I'm going to do my slope, up 1, right 1, up 1, right 1, as many times as you want to, or we can go down 1, left 1. And we can see there we're actually going to connect these. So this is, again, your entire graph right here. And it'll continue down here. That's the entire graph. Now this is only defined for the values greater than or equal to 1, so, or negative 1, sorry. All the values, here's negative 1. All the values to the right is where this is defined. So anything to the left, I'm going to get rid of. So anything to the left of that, I'm going to get rid of it. There we go. I erased too much. All right. So again, greater than or equal to negative 1 means at negative 1 I'm going to fill in the dot so it's filled in now. I'll make sure we got some arrows on there. All right, there's number 3. Number 4, absolute value of x is going to be my blue graph. So this is the blue one right here. All right, now y equals absolute value of x. Again, if you don't remember what it looks like, go ahead and make up a table. All right, so let's just use like negative 2, negative 1, 0, 1, 2, and then plug those into the absolute value of x. Okay, this will give us our y values. So negative 2, if I plug it in there, I get 2. Negative 1 gives me 1. 0 gives me 0. 1 gives me 1. And 2 gives me 2. All right, so 0, 0. Negative 1, 1. Negative 2, 2. 1, 1. 2, 2. There we go. All right, so let's connect the dots. Try and do my best here. Again, I haven't had much success here with this, but we'll try it out. Oh, that wasn't too bad. And on this side over here, I got this line. That wasn't bad either. Okay, I'm only defined here for all the values less than or equal to 2. Okay, less than or equal to 2. covered up my line too much there, so let me back up. So here's 2. This is only defined for the values to the left of this. So I'm going to go ahead and grab my eraser, and anything to the right of 2, I'm going to get rid of. So let's get rid of all that stuff. What goes at 2? For the blue graph, what goes at 2? Filled in circle. Good. Red graph. Y equals x minus 1. Y equals x minus 1. So again, I'm going to start out with my slope is the number in front of my x, which is just a 1. B is the number after x, which is negative 1. So let's put it all on the graph here. I'm starting out with a y-intercept at negative 1. My slope of 1 says up 1, right 1. Repeat, up 1, right 1, up 1, right 1. Or we could go down 1, left 1, down 1, left 1, until the whole thing is drawn. So we draw the whole graph here. We just keep going, up 1, right 1, up 1, right 1, like that. And again, this graph is only defined where x is greater than 2. So here's 2. I only want the values that are greater than this. So anything less than this, I'm going to get rid of. So erase it. I'm going to erase my little note here too. And at the end of this, because this was just greater than, that means it gets an open circle. So they don't always have to connect. And you can see I wanted to give you some examples where they don't. So right here, these 2 lines do not connect. Okay, you're allowed to have a little gap there. That's okay. That's the last example there. Again, you're allowed to have a jump. That's okay. But the main thing that you need to do here is graph each function individually. Get rid of the stuff you don't need. And that's your final answer. All right. So if you have any questions, let me know. But otherwise, work on your worksheet and let me know if you have any questions then.